Rapid advances in materials technology have catapulted the textile industry into a new era, with the production of once unimaginable innovations now made possible. One of these innovations includes the use of conductive yarns in textile pieces. There are many different types of conductive yarns used within the textile industry today. Kitronics conductive thread consists of thread with a nylon core that has been nanoplated with silver to make it conductive. This thread has a low resistance of 40 watts per meter, a breaking strain of 42 kilograms, and comprises of 96 individual filaments, separately coated with micron-thick layers of natural silver. The construction of the yarn consists of 16 filaments which are wound together to form an initial twist. 2 of these twists are then twisted together, and finally, 3 of these twists are combined to form the finished thread. The conductive thread is approximately 18 denier and does not fray. Conductive thread can be integrated into a fabric, like all other sewing yarn, but it electrically conducts, which allows electronics to be integrated into textile pieces. Another type of thread is stainless steel thread, which is made entirely of stainless steel and therefore does not contain a thread core. It has a low resistance, with the lowest resistance threads being thick and more like twine than thread, making it difficult to stitch with. This thread will not oxidize though, which can sometimes occur when using silver-plated yarn. Both fibers are safe to wash, making conductive thread ideal for use in a range of e-textile products. In order to create an electronic system that will run through a textile garment, an electrical circuit needs to be made. An example of an electronic circuit board that has been created to be used in conjunction with conductive yarn and fabrics is Arduino's LilyPad program. Arduino is a highly advanced software company that has created microcontroller-based circuit boards. These boards are programmable by the user using advanced computer software, which allows textile designers to maintain control over how their electronic materials are activated. These boards are able to read inputs such as a finger on a button and use this information to generate outputs, which can then activate a motor, turn on an LED, or publish something online. A circuit is a network of electrical devices. It is generally a closed loop that includes a power supply and other electrical elements like LEDs and switches. The loop structure enables the flow of electric current from positive to negative. The LilyPad circuit board requires a power source in order for the yarn to be activated and generate electricity. Lithium polymer-based batteries are a popular type of rechargeable battery. They contain large capacities, which mean that these batteries can hold a vast amount of energy in a very small package. They are also lightweight and can be produced in almost any shape or size. Currently in development is the printing of solar cells onto fabrics to generate sustainable energy. In 2011, an online article was published by MIT News stating that MIT had developed materials which would make it possible to produce provolactic cells on paper or textiles. Organic provolactic circuits are monolithically fabricated directly onto a variety of common paper substrates using oxidative chemical vapor depositions to vapor print conformal conductive polymer electrodes. The paper photovoltaic arrays produce more than 50 volts. This amount of power is commonly used in electronic displays, ambient indoor lighting, and can be flexed and folded without loss of function. With the e-textile market growing at a rapid pace, the use of solar-powered fabrics will pave the way to create a sustainably viable e-textile fabric for the future. In the market today, conductive yarn is used for many purposes. Thermogloves are a brand that have created battery-operated garments which utilize the use of conductive fibers. The gloves they have designed are made up of thin, elastic material that can mold to the shape of the user's hand. Heat is conducted along this material using thin and flexible carbon fibers that work to evenly distribute warmth through each area. This device contains the ability to set 3 temperature levels which allow the wearer to select the temperature that is ideal for them. The system is controlled by an on and off button accessibly located on the outside of the glove. Its system is powered by a lightweight and rechargeable lithium polymer battery. The battery is then stored within a pouch that is sectioned off, and specialized LED lights placed around the power button indicate the status of the battery power. These gloves are helpful for men and women suffering Raynaud's syndrome or arthritis, and they help to relieve pain caused by such conditions. Project Jacquard is an experimental project being conducted by Google using conductive threads. By weaving these threads into clothing, they are creating touch-sensitive panels that work in a similar way to smartphone screens. Google's Advanced Technology and Progress Department is exploring the integration of conductive threads into textiles to recognize gestures, such as being touched, and to then send signals to computers, which can translate these gestures of the users into controls. The yarn is created by replacing strands of threads with thin metal wires or conductive polymers. It is highly conductive as well as flexible, which allow it to be used in weaving machines. The main focus for the Google team is to create technology that interacts seamlessly with textiles, to minimize the size of technology so that the components necessary are embedded into them during the manufacturing process. The goal is to weave interactivity and input devices into textiles materials, which is the first step towards integrating computers into clothing. Electronic Traces is a design that incorporates conductive thread, the Arduino LilyPad program, and a mobile application to allow dancers to recreate their movements in digital pictures. Through the foot's contact with the ground and by use of conductive wires, the LilyPad program records the pressure and movement of the dancer's feet and sends a signal to an electronic device. An iOS and Android application then allows this information to be shown visually. Dancers can interpret their own movements and correct them or compare them with the movements of other dancers. E-textiles are revolutionizing the fashion industry, with conductive thread allowing electronic technology to seamlessly integrate itself into wearable pieces. The future of textiles is buzzing with endless possibilities, from the potential to download new colors and patterns into garments to scrolling through network interfaces on your sleeve. The unimaginable is now being synthesized, and it all begins with an idea.